Well, let's have a look at the patterns for the Cubix. A plus b cubed, when we expand it out, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. If you look at the expression, there's the pattern. The powers start with a, and each term the powers are going down by 1. So a cubed, a squared, a to the power of 1, a to the power of 0. And the powers of b are going up by 1. So in every term there, the two powers add up to be 3, because it's a cubic that we're doing. And in fact, every expansion is like that. If it was the power of 4, I'd have a to the power of 4, then a cubed b, then a squared b squared, then ab cubed, and then b to the power of 4. The question is, what's the coefficient going to be? And the pattern for a cubic is 1, 3, 3, 1. There's this thing called Pascal's triangle. Do you know the Pascal's triangle? Okay. That basically tells you the coefficients as you go along. Starts off with 1, because when you've got a single term, but the next row is 1, 1. Well, that's just your binomial. But now you go to 1, 2, 1. That's your perfect square. A squared plus 2ab plus b squared. Then it goes 1, 3, 3, 1. There's the pattern for the cubic. And so if we were to keep going, it would then go 1, 4, 6, 4, 1. So the expansion for a plus b to the power of 4 would be a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. And if we wanted 5, we could keep going. So if I come from 1, 4, 6, 4, 1, that's going to go 1, 5, 10, 10, 5, 1. And the algebra will start at, oh, here we go, a to the power of 5 plus 5a4b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the power of 4 plus b to the power of 5. Anyway, you get that's the pattern. Everything's got this beautiful pattern in mathematics. If we remember the patterns, these questions become a lot easier. What happens when there's a minus in the middle? It just means the signs now alternate. Plus, minus, plus, minus. Same with those other ones. You'd start at plus, plus, minus, plus, minus, plus, minus, all the way till you get to the end. Difference of two cubes. A minus b, a squared plus ab plus b squared. Again, let's have a look at the pattern of that. It starts with a minus b. Just like the difference of two squares starts with a minus b. In fact, the difference of two anythings always starts with a minus b. The second factor then, once again, we have that lovely pattern. A starts at 2, then we've got AB, and then we've got B squared. This time, the two powers add up to be 2, one less than what we're looking for. The coefficients in this case are always 1. The coefficients don't change in this. So A squared plus AB plus B squared. So if I had A to the power of 4 minus B to the power of 4, yes, I could do it as difference of two squares. I could go A squared minus B squared, A squared plus B squared, but I could now also factorise it as A minus B, starts with that. Then I would go A cubed plus A squared B plus AB squared plus B cubed, and so on and so on. So that pattern again is always there. If it's a sum, then it's a plus in the first one, and in the second one you have the alternating. When you project this one through to other powers, the sum only works for odd numbers. No? We don't have a neat factorisation for the sum of two squares, for instance. A squared plus B squared. It's not a neat factorisation. Only works for odd numbers. Okay, so 2a minus 5 all cubed. So that pattern, now you may or may not write that like down. You might be doing that in your head, but you're saying, hey, first term cubed minus 3 times the first term squared, the second one to the power of 1. Those powers are going down by 1 for the first term. The powers are going up by 1 for the second term. The coefficients 1, 3, 3, 1. Tidying it all up, and there we go. So I want to factorise x cubed. It is the sum of two cubes. So it starts with, well, again, you're thinking x cubed plus 2 cubed. So in the first parenthesis goes x plus 2. But now we play with the powers again. Powers of x go down by 1. Powers of 2 go up by 1. The classic mistake in the second parentheses is not to write 2x, but to write, what do you reckon? 4x. Because we're so used to doing the perfect square. But that's not what this is. It's just AB. Here's a difference of 2 cubes. Y cubed minus 3a cubed. So again, we start with the y minus 3a. Powers of y are going down by 1. Powers of 3a are going up by 1. Because this is what I was saying about the generalisation. If you have a to the n minus b to the n, a minus b, it always starts with, that's what I'm saying, powers of a going down by 1, powers of b going up by 1. So if we did do that power of 5 I was talking about, there it is. Only works for odd numbers, I said. And the reason it only works for odd numbers is because you can rewrite it to make it a difference instead of a sum. Because -1 to the power of an odd number will always be negative. So I can write it as minus. So that's why it works for that one. But it won't work for even numbers because I can't get a negative number to an even power and turn it into... All right.